welcome back. In the previous lecture, we learned about controlling the state of a digital pin through sending GET requests with your web browser. What if you had to control two pins at once, and if you had to send over values other than 1 and 0s? In this lecture, I'll show you how to do something like that by demonstrating how you can control a DC motor through your web browser. You may remember from lecture 20 that to properly control a DC motor, you need two bits of information: speed and direction. So in this demo, we'll look at how we can send speed and direction information to the Arduino from the browser and code it in a GET request. This makes for slightly higher passing complexity on the Arduino, but nothing that we can't handle by building on our current knowledge. Okay, so in this demo, what I want to show you is how to control the motors in this toy car, which I still haven't returned to my kids, using your web browser. So remember back, I think it was lecture 20, when we looked at how to do the connections using this L298 breakout board. It's a motor controller. And in this example, I'm going to go ahead and upload the sketch, show you how it works and what it does actually, and then show you how it does it. So uploading, let's go to 192.168.111.177, and this is the interface it provides. So I can go full speed ahead. So this motor is spinning one direction, then I can go full speed back, reversed, and I can have I've got a choice of intermediate speeds as well. You can be as detailed as you like about. You could imagine here you can use perhaps a slider in order to have fine control over the speeds. That's what it does. But notice up in the URL, similar to the URL structure you used in the previous lecture, but now instead of just controlling one thing every time that we are submitting this form, we control two things. First is we control the speed, and I have a number here which represents the digital pin where I assign in my script the motor control, the motor speed, and I can set that to an arbitrary number. So it could be, let's make it 120 for example. And then I've got a separator between my multiple key value pairs. So that I use the ampersand sign as a separator. And I've got direction, the keyword, and a number which represents the digital pin which controls direction for this motor. In this case is digital pin 4, and I can set a value 0 or 1. So if I submit that, and I've got speed 120 going one direction, if I change that to a 1, then I've got the same speed but the opposite direction. So this kind of URL provides quite good scalability and flexibility if I want to connect multiple motors. Another nice little thing that I've got here is to improve the usability by having a little bit of JavaScript attached to this on-click JavaScript event. This way I don't have to provide the button to submit each form, which would require 2 clicks, one for the radio button, one of these, plus the submit button, 2 clicks. I want to be able to just click on a radio button and have the form submit itself. So it's a neat trick to remember. You can just say this form submit, open, close parentheses. So to recap, in terms of parsing, the requirements now are slightly more complicated to those in the previous example, in the previous lecture. we still need to be able to detect the question mark because that tells the Arduino that instructions follow. But now we also need to be able to disassemble a set of instructions because now it contains two key value pairs and those are separated by the ampersand sign. And for each key value pair I need to be able to detect the pin number and the value that I'm assigning to each pin. You could use Pastebin to have a look at this in some detail, or of course we could use the inspect element feature network as we saw earlier. But once you get the principles right, now just looking at the URL is enough to tell you what you need to do in your sketch. So let's have a look at the sketch itself. The thing that really changes here is the pass get request function. Everything else is the same. So I'm going to skip everything else and go to parser, pass get request. Oops, pass get request. Now what's happening here is I'm looking for the delimiter using the index of function that's available with strings, just like we saw before. So this character is important because it represents the delimiter that separates the two sets of instructions. Then I look for the index where the word or string of text speed appears. Make a note of that in here in the speed underscore index integer, and then I use this information to find out which pin I'm trying to manipulate. So that is 5 cells to the right from speed index. So speed index would be here. So count 1, 2, 3, 4, 5 to give me the number of the pin that I want to manipulate. And remember, I subtract 0 in order to get the decimal numerical value instead of the ASCII table decimal values for the character that appears at this location. In this case it happens to be 5. I store that in motor number integer variable. Then this code looks a little bit messy, and I had to use it because originally I was trying to use a substring function to find to record or to extract the number, in this case 127, from the URL. The problem here is that this can sometimes be a single digit, some other times maybe 2 digits, some other times maybe 3 digits. I'll explain. Let's say that I make that 10 instead of 127. I'll make that 0. Right, so now we've got 10 is a legitimate value for the speed, or it could be 5, which is another legitimate value, or it could be 155, 3 digits. Right, so we don't know beforehand for sure how many characters the value for the speed will be. So a way to go about this would be to use the substring. Now substring, we've got to the documentation. Substring is a very useful function. So what I like about it is that you can give it 2 indexes of a string, and it will extract the text of the string in between those 2 indexes. But it doesn't always work as advertised. This seems like in the current version of the IDE there is a bug in it, and sometimes it returns strings, sometimes it doesn't, even though it exists. So I had to go with something a lot more basic than that. What I do is first I declare an array of characters, and because I know that the value for the speed will never be more than 3 characters, I have created the array of cars called speed_value_array of size 4. So I need 4 because the 4th character is going to be a null character. A null character tells the Arduino and its processor that we have reached the end of the string in this array. So just a requirement for arrays of characters. Then I'm doing a loop. I'm starting to go through the string. I'm starting to go through the string down here from position speed index plus 7. Okay, speed index plus 7 is the position of the first character of the value. So speed index is the position for S. It counts 7. 1, 2, 3, 4, 5, 6, 7. And that signifies the first position of a character that represents the value in my value pair, in my key value pair. So speed index plus 7, that's the first position that I'm going to start extracting the value from. And that goes up to the delimiter, the ampersand sign. So as soon as it hits that, or not equal to that, but as soon as it reaches that, it's going to stop reading values out of the string, the SDR string. So I am starting to store values in speed value array one by one as those are being extracted from the string that contains the instructions. I'm going to go through this loop 1, 2, 3 times depending on the position really of the ampersand sign. If this doesn't make sense at first, try to run this loop manually and see how it works. Then what I have here is a string of characters, and I need to convert that into an integer. So there's a very useful function in C which converts text to integers, or an array containing characters, A stands for array, to integer. So because I've got an array already, which is this, that contains the characters that represent the value that I have captured from the URL, I use @OI, and that converts whatever characters I have here to an integer, which then I can use. So far I have managed to capture the information in the first of the 2 key value pairs. Now going to do the same for the second key value pair, and that happens here. I'm using the delimiter as a base for extracting those values. So delimiter index plus 10 gives me the number 4 in this case. So 1, 2, 3, starting from the ampersand, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That grabs this character, and I will subtract the ASCII decimal for 0 to give me the actual decimal that is present at that location. Do exactly the same thing for the direction value. I only expect a single digit there, so I can just add 12, which is how many characters you have between the delimiter and the 0 here. Subtract the 0, and then that gives me the direction value as an integer. Yep. So now I've got all 4 pieces of information I need. I'm going to send those to the execute instruction function, I pass the motor number, the motor speed value, the direction number, and the direction value. And just like we saw back in lecture 20, I pass those to the motor control breakout board, which then instructs the motor to turn a particular way, a particular speed. And give it 30 milliseconds for the motor to complete its adjustment of its state. In this lecture, we learned about sending two key value pairs that contain information for updating the state of a connected device, a motor in our case. From here onwards, complexity can, of course, increase, but it can be managed with a bit of planning. I have two exercises that I highly recommend you attempt here. The first one I read is easy, because you can deal with it without having to expand on what you learned here. It's just for a bit of practice. The second one is harder because you have to go beyond what you've learned here. You can use the principles regarding designing a flexible URL structure, but after that, you're on your own. Good luck and let me know if you get stuck anywhere.